Hi guys, currently our little compiler project is still in a very early stage. We just have a few source files, a few header files and a make file. And you saw that we started with a very simple implementation of the Lexer, improved it step by step, and we will continue like that. And you will see that sometimes improvements are not actually improvements. Sometimes you mess certain things up and then you want to go back to a stage where you know things were working. And currently the only way to do that is by making copies of the directory and giving this copy some meaningful names like this was working on this day. But this is certainly not a way to proceed. And there are actually tools for helping you to manage software projects, and one of them is Git. And we will use this in our class. And in this video, I want to show you how to get started with this tool. In the demo, I will first show you how to create a so-called bare repository on Theon. And think of this bare repository as a database managed by Git. And in this database, Git will store certain stages of your project and what changed from one stage to the next. You will never work directly in this bare repository. What you actually do is you make a clone of this repository, and this can be on the same machine, but in a different directory, of course, or on your local computer, for example. And in this cloned repository, you can add files, you can change files, and you just do some work. And when you reach the point where you say this is worth to be saved in a snapshot, you can commit certain changes to your local repository, to this non-bare repository. You also can give this snapshots some name, some tag, and after a while, when you collected useful snapshots, you can publish them. You can push them to the bare repository on Theon. And this has the advantage that later maybe you want to resume your work on a different machine. Then you can make a clone on another machine. You also, of course, can continue in this clone that you already created before. And this has the advantage that you have one managed database, maybe on a server that makes backups. And even if you lose your local repository because you have a crash on your computer, you don't have to worry. So this will already be a big advantage. And then, of course, you can also use such bare repositories on servers managed by others, not by us. For example, by GitHub or GitLab. I also will show you how to import your repositories there. The command for using Git is simply Git, and its first argument is always the Git command. And the first command I want to show you is the config command. I will use it to set up my username and my email address. And because I want to use this information for everything that is related to Git, I use this option global. And then I specify the username as my full name. And I also want to specify my email address. Of course, this makes most of all sense if you're working on a project together with others. Then you can keep track of who is always committing this great commits and who is committing this not so great commits. But it also makes sense if you work on a project just by yourself, because maybe later you want to publish this project and then others might join this project. Now this will have created some file in my home directory, file.git config with this information. And on my local computer, I already did that, so I have here basically the same thing. And now on Theon, I will create one directory where all my bare repositories will reside. Maybe in general I will have more than just one. And here I create this new bare repository with the init command. And because it's a bare repository, I use this option, and then I give it a name. And it would be okay to call it ABC, the name of our compiler project, but traditionally you use this extension .git. And that's it. Now you get the message that it was created, that its default branch is master, and that you can change it, but this is not relevant right now. We just use the defaults. And now in some other directory, so I first go back to my home directory, let's say subdirectory for all my things related to this class might contain repository where I work actually on this compiler project. So initially I do not have that, so this is empty. Now I first create a copy, a clone of this so far empty repository. And for that I use the clone command. And because this is on the same machine actually right now, I just can specify the path to this bare repository. So it's in my home directory, in this subdirectory mygit, and this is the directory where this repository is. And then I clone it, and then I get this warning, oh, this is an empty repository. Well, of course, because we haven't started yet. And now you see we have this subdirectory ABC without this extension.git. And now I change into it, and yeah, as I was warned, it's empty. Now, of course, we now already have some content. I just could copy this content into this directory and show you how to import the current state of the project. But let's assume first that I start from scratch. Then I would, for example, begin with some README file. And here I just specify what this project is about. So ABC stands for ABC is a bloody compiler. Okay, and now we have some file in this local repository. And with git status, you will now see the following, that we have an untracked file. That means it's so far not part of this repository. And if you would modify it or delete it, Git would not care about it. And now we want to add it to our repository. And as Git suggests, you can use git add to add all these untracked files. And then I first show you how to do this by explicitly typing in the name of the file. And then if you use the status command again, so now it is tracked, but Git tells us that it's so far not in the local repository stored. And I want to change that. I want to make a snapshot of this file and add it to the repository. And for that, I use the command commit. And then I also can specify this file name explicitly. And then I can leave here some note. What is this file about? And this is just the initial README. Maybe like that. And now it's in this local repository stored. And now I could do more modifications to it. For example, I could add here this markup tag and provide some additional information. So something like this is our compiler project. And then you can use git status again. And then you see in your local repository some tracked file was modified. And so far this change is not part of this local repository. And if you would delete it now, you would lose all these changes. If you want to keep them, you have to commit this again. And then you can specify here that you updated the info. And maybe we do another change to show you also some other command. Let's add here in some subsection instructions how to compile the project or how to use it. And then, for example, you would specify that you have to use make to build the project and so on. And then again, we check with git status what was modified. Now assume that we already would have lots of files and some of them were modified. And sometimes you forgot, did I just add some debug code to some file that I actually do not want to have in my repository? Then you also can use this git diff command, and then you can specify one file where you want to see what was changed compared to the last commit. And then you see that Git is actually using diff for figuring out what has changed. And this also, by the way, means modifications are not about whether a timestamp has changed. It really means that the content of a file has changed. And here you see that some lines were added. And now we would say, okay, this is certainly a change I want to keep, so we would commit it again. Here you also can, by the way, use this option -A, and this means that you want to commit all tracked modified files or also all tracked new files. Here, of course, this is just about one file. And then we have here more info. And like that, you would continue. Then you will see that you get a list of commits in your local repository. So far, this is still not part of this bare repository. That means if you would now delete this directory, everything is gone. So now let's assume we are happy with this initial README, and then we want to store this final result that we have in this current local repository on this bare repository. And for that, you have to push this state. And you push it to the bare repository, in this case on Theon. And now I will go back to my local machine. And here I want to resume the work. I actually want to work on this first exercise. So I first make a clone of this repository stored on Theon, and I want to use the SSH protocol for accessing this repository. And I have to specify currently the full domain. I can provide you information on the website how you also like for using SSH itself. You can specify shortcuts, and then also the full name of the full path to this repository, to this bare repository. So in this case, in my case, it's /home/numeric/lane/mygit/abc.git. And now I have here a subdirectory abc, and it contains this current readme. Now, if you also use here git log, you see that you get a full history of all commits. And actually, you could go back to any previous commit. But this makes sense, of course, later, when you really have some content in this project and when you really messed up certain things. Now, let's assume that I'm now starting with my exercise. And I, of course, already prepared this. I have here in this directory step 0, the result after the first exercise. So I just will copy all these files to here. And then you see I have here new files. This file testlexer.in is some test file with some things that should be tokenized. And I have this make file and I have this source files. So currently we have this situation that this test program xtestlexer can read something only from standard in, but if I redirect this test file to standard in, then it currently can identify certain tokens. And so this is a state that I want to commit again to this local repository. And if I now use git status, you will see that we have some files that I certainly want to be part of the repository, the source files, the header files, and the make file, and also this test file. But I do not want to have these object files or these dependency files because they are kind of platform dependent or will be created anyway the next time I do a make. So I first make clean, and then I check again with git status what is untracked, what has some modifications. So far, everything interesting is untracked, so I just use add together with this wildcard. Git status tells me that I have new interesting files that I want to commit. So I commit all of them, and then I say this is the result after the first exercise. And then, of course, I also want to push this to the repository, to the bare repository on Theon. So git push. And actually, if I now again look at the log, then of course I just see that I have another commit, but now we have kind of an interesting state that after this commits, we have something working. The Lexer already could recognize certain tokens. And for that, I want to tag this state of commits. And for that, I use the tag command together with this option -a, which is usually the option you want to have for annotating this tag with some short name first, version 0.0.1, and some more descriptive name or message. This is the result after the first exercise. And then I also want to push this tag to Theon. By default, these tags are only kept local. And for that, you have to use git push origin. That's Theon. Where is this bare repository stored? And the default name for that is origin. And then --tags. And now for some reason, I want to continue my work on Theon, not on my local machine. So I can go back here to this directory with this clone of this repository. Currently it's not up to date, but if I use git pull, I get the latest commits. And now I could do this second assignment. And I also prepared that already. In step 1, I have the state after we added this line numbers and column numbers so that we get more information about the tokens. So I just copy this to here. And then with git status, you see that certain files that are part of the repository were changed. Let me show you what in this current state the program is doing, the test program for the Lexer. I now have this information about in what line and what column a certain token was found. So this seems to be nice, so I want to commit it, but first I just check with git status whether everything is tracked that I want to keep. And we see the untracked files are just those files that were generated by make. So it's fine. So I just use git commit -a. And this is after the second exercise. And this again is something that is worth a tag. So again, I use git tag -a. This is now version 0.0.2. And in the message, I say this is the state after the second exercise. And then again, I push the tags and I push the commits. First the commits and then again the tags. Okay, now I somehow will by accident mess up things. Let's say, for example, I delete a few lines by accident. For example, next 18 lines. And I still will commit it. So I will commit the changes here in lexer.c. And here I, of course, have to specify either the file name or that I want to commit all changes. And here the message is just bug. Now we have two cases. Either I just have a local commit with a bug, or I already have pushed it. If I haven't pushed it, it's actually kind of easier to undo things. with git log, we see that actually we just have to go back one commit. And for that you can use the command reset. And there are also options to this reset. What you would like to do in this case would be using the option hard to do a hard reset. And with head and then this head symbol, you actually can go back one commit. You also can specify here this this identifiers for the commits, the so-called checksums. But let's go through all these different options. With that, I could go back one commit. If I would specify some of this identifiers, this checksums, I could go back to a specific commit. And most of all, I also can just specify this tags, which makes it easier to go back to certain notable commits. And then everything is undone, no harm done. So now with git log, you see, we just have the good stuff. But of course, we also could really mess things up. That means we push the bug and then we have to undo it on the server. So let's do this again. So now this bug is in the commits in this bare repository, and now let's assume we will figure this out later. For example, if we continue later our work on the local machine. That means here I do again a git pull, and after I get all these modifications, I try whether this is still working, and then I figure out something is wrong. But because I somehow remember that in the past there was some time after commit when things were still working, I just look at this git log and then I see, okay, this is the current checksum of the current commit. So step by step, I just go back. So I copy paste this checksum, and then with git reset hard, I check whether this state is actually still working. So now I can check if this was this state after a commit where things did compile and work. So at least it compiled, and yes, it also gives me this line numbers and columns for each token. And now I want to go back to this commit, and I also want to go back not just in my local repository, but also in this bare repository. Now if I simply would do a git push, I get this message that it's not so easy because you're going back to a previous commit, and here you have to specify that you're serious about that you really want to throw away certain things, and then you have to use this option force. And now we can go back to Theon. Where we actually right now have still this state where things are not working. Let's make here make clean and make. So this is something we should have done before this push. And after git pull, we get this message that you now have to think about whether you want to discard this recent commit and want to go with what is now the current head of the bare repository, or whether you want to keep this last commit. Well, in this case, we know that this last commit was wrong. And if we have a look at git status and most of all actually git log, we see that we are one commit ahead of what is stored in this bare repository. And that means in this case, we actually do not want to keep this commit, this last commit, and we actually also want to go back to what is now the head of the master. So here we simply can git reset hard hat and then head again. But whether you want to do that in all cases depends. Maybe sometimes you made some modifications which were buggy, but you do not want to completely discard them. Then you want to use one of these options that Git suggested you, that you actually want to merge it, fix them, and then commit them again. So these are actually the tricky things. Here we just keep it simple. We undo the last commit. So in the demo, basically everything was going very smooth. And even if we had some bug and even committed this bug, we simply could completely undo this last commit, go back to a commit where things still were working. And as long as you're not interested in keeping the buggy commit, partially fixing it, basically you do not have to deal with much details about Git. But however, I was ignoring certain situations that might sooner or later come up, that you, for example, forget to do a Git pull before you do some changes in a repository, and you might work on more than just one cloned repository, and then you have to deal with things like merging different commits and solving certain conflicts. And we will deal in another session with such cases. What I still want to show you here in this video, in this session, is how to use these fancy websites that are hosting Git repositories for you. And actually you can create an account there, and then you can import the repository from your local machine to there. And I just showed you this on the example for GitLab, which is next to GitHub, a very popular site for that. So this is my account on GitLab, and of course, setting up the account is kind of self-explaining or very well explained on all these websites. And you also can leave there some public keys so that you do not have to type in passwords when you push something or pull something from your repository. And then I simply create here a new project. And what this is doing behind the scene is, of course, making a git init bear. And here I just give this project the name ABC, and I want to import our current repository, so I do not want to have a README file. And then I simply create it, and then you get on all these websites some information about how you can import an existing repository. And basically you have to follow the instructions here. So what I will do is, most of all, copy this line here. Here they tell you that you have to rename the origin of this project. The origin is how Git internally stores where is this repository coming from, this bear repository. So far the origin in our case points to Theon, and they want to of course use their repository as the default repository. Well, I will do it like they say. Okay, so I first have to rename this current origin into something else. I will just rename it into Theon. And then I have to add as new origin this GitLab repository. And then I have to push my current state to this new repository, as they specified with this option -u. And -all. And then I also want to push all my tags. And that's actually it. Now, what I actually can do is I now could push certain things to Theon and also to GitLab. Sometimes this makes sense. Sometimes you want to keep certain things internal. And after a while, when they are good enough, you want to publish them on a website where people can make use of that. It's up to you whether you want to support this complexity. Now let's go back to this website and see how you can use this nice interface for looking what certain commits did. And now if you go back to this repository on the website, you see that you have all these files. And you also have the complete commit history. Now here you also see that I have to fix certain things because I was somehow used to this markup dialect from GitLab, and this hashtag is here obviously in GitLab not used as marking a title. So you also can do changes directly here in the web browser, sometimes convenient for minor things like here. So here I just edit this. And here the syntax is that you have to underline it with this equal signs. And then you also can leave here some commit message, fixed markup for the title. And then commit the changes here. Okay, and now it looks a bit nicer. So let's also see that you, for example, can see here the history of a certain file. You can see what the last commit was changing, that certain lines were added. This, of course, is just the same that you would get on the command line with git diff. I mean, after all, this is just a web interface for Git, so it's not providing some additional features. It's just providing some interface to the features that you already saw before. Of course, on the website, I can provide you more information about the Git commands that I showed you in this video. Maybe also some additional links to tutorials and maybe also links to some more advanced features. But of course, we also will discover, just by needing them, more features over the rest of this class. For this video, that's it. See you in class.